Picture this. Your client calls you at 2 a.m. because their brand new fuel monitoring system just triggered 47 theft alerts in one night. You investigate, and guess what? No fuel was stolen. It was just parked on a hill. Meanwhile, their fully monitored fleet is quietly bleeding $40,000 annually in fuel that simply vanishes from their data systems. Welcome to the dual tank paradox. The more sophisticated we make these systems, the more spectacularly they can fail. Let's have some context. We're living through a strange contradiction in our industry. Fleet managers are demanding AI-powered analytics and real-time theft detection. But the foundation, basic fuel level data, is often complete fiction. Problem isn't the sensors, it's not the software, and it's definitely not the hardware. It's something much more fundamental that we've somehow forgotten how to do properly. Today, we're diving deep into why dual tank systems have become the ultimate stress test for telematics deployments. We'll uncover the hidden costs that are quietly destroying return on investment, expose the calibration shortcuts that turn premium hardware into expensive paperweights, and give you a battle-tested framework for turning these problem children into profit centers. Because here's the truth. Master dual tanks, and you'll master just about any fuel monitoring challenge your clients throw at you. Greetings. Welcome to the Navixy podcast. My name's Steve Statler, and I'm joined today by two of Navixy's experts, Nenad and Kenneth Michael. Nenad is the Technical Solutions Engineering Manager at Navixy, and he brings over 13 years of hands-on experience from the trenches of GPS tracking and telematics, having built his expertise at Almac Security Systems before recently joining Navixy. What makes Nenad particularly valuable for this discussion is his extensive field experience with the exact problems we're addressing. He's been a regular at major telematics conferences across Europe and the Middle East since 2014, building relationships with manufacturers and learning about emerging solutions. His background includes managing large-scale deployments where dual tank monitoring systems either succeed brilliantly or failed spectacularly, giving him real-world perspective on what separates good implementations from expensive disasters. Kenneth Michael is a senior technical support engineer at Navixy. Kenneth brings a unique blend of enterprise system engineering and telematics expertise to the conversation, with nearly 6 years at Cerner Corporation managing healthcare IT systems before joining Navixy. He understands both the critical importance of data accuracy and the challenges of supporting complex mission-critical systems in the field. Kenneth's perspective is particularly valuable because he approaches fuel monitoring challenges through the lens of system reliability and data integrity. Having supported healthcare systems where data accuracy can literally be life or death, he brings a rigorous approach to calibration procedures and diagnostic processes that many in the telematics industry could benefit from adopting. Okay, guys, let's kick it off. First question to Nenad. We're seeing fleets deploy increasingly sophisticated fuel monitoring systems, multi-input telematics devices, AI-powered anomaly detection, real-time theft alerts. But field reports indicate that 40 to 50% of fuel tank installations still produce unreliable data due to calibration shortcuts. Are we building Ferrari engines and putting them in vehicles with square wheels? What a horrible thought.
Yeah, imagine this. You're invested in the very high-tech telematic equipment, very expensive telematics equipment, and then you decide to not do that calibration, And that is, like you said, like you are putting a Ferrari engine on the square wheels vehicle, because this calibration is fundamental in this case. Why is that calibration is so important? I mean, I encountered many times from my clients, from my previous experience, that famous sentence, just get this done, as soon as possible. But we cannot do this as soon as possible. Calibration is the process. Calibration is the presentation of that data. Because without calibrations, you're getting only raw data from the fuel level sensor. And that is not something that needs to be presented to the client. So I got a lot of questions from the client. I have 20 same trucks, same model, same age. Can you do just one calibration and then copy that calibration on different vehicles? Use one calibration for 20 vehicles. I mean, we can do that, but data is not going to be precise. Data is not going to be valid because every fuel tank is the story for itself. We need to map that fuel tank. We need to map every bump, every irregularities, every curve on that fuel tank. That is very important, and we need to do that calibrations for each fuel tank separately. We need to close the transfer line between them. We need to calibrate them on the proper way. So when we are talking about the calibration, I divide that into steps. Step number one is to talk with the client and tell them why this calibration is so important, why they need to get real results, to transform that data into liters, not to have just raw values or some unprecision data. Step number two is to prepare your workers, your technicians on the field for the work, for the actual work, for that calibration. So if you're an expert in this job, you will not rely on your client to prepare everything for you, to prepare fuel pumps, to prepare some garage or hall or something like that. I mean, it would be great to have all of that, but you need to think about in a way, we are the experts, we are the bring all the equipment, Previously, we had mobile pumps, that mobile pumps needs to be certificated and for precision, of course, and that fuel mobile pumps needs to be recertificated on every 6 months. So that is something that you're bringing to the client. Equipment. Also, you need to provide clamps or valves to shut down that transfer between the fuel tanks. You need to take care about your technicians on the field as well. You need to ask client, can you provide some kind of, protected area? Because that guys are doing all of that outside, high temperatures, snow, wind, rain, everything, an environment affects them as well. And you want to avoid that. You want to make them comfortable and concentrated to work. And number three is calibration itself. I mean, that ritual of calibration. And what does that mean? I'm talking about the calibration, but what is the calibration? We need to set the values from 0 until the tank is completely full. So imagine you have 600 liters fuel tank. You will want to divide that into precise 20 fillings. That's the 20 fillings is going to be around 30 liters each. So on my procedures, I was insisting that the installer technician on the field cannot do all of that job alone. But he needs to have some control from outside, and that control is our technical support. So that technical support is tracking values all the time from the office. First thing that they need to do is to set that device for calibration. When you're setting GPS device for calibration, that GPS device needs to transmit the data to the server, to the platform, on every 5 to 10 seconds, just to follow all the values all the time. So basically, after that is done, the tanks needs to be completely empty. Fuel level sensors needs to be installed in each fuel tank, and then calibration can start. Ground zero is established, zero value is raw value is established, and then technical support can call that technician on the field and said you can fill 30 liters. After 30 liters is filled, they need to wait. They need to wait for fuel to settle up, inside the fuel tank, because fuel tank is full of chambers, irregular curves, and so on. You need to cover all of that. So after that is done, after they're waiting for a few minutes, we can continue with calibration. They can fill next 30 liters and so on until that fuel tank is completely filled until the up, And the reason why I'm have this procedure for technicians not to do that calibration on its own, because maybe they will not care so much about this calibration. We need to take care about the data later, and that client is going to call technical support. He's not going to call technician on the field who done the installation job. So that is, two-way authentication in this case. We need to track the values. Also, they're closing that transfer line between fuel tanks. And when they're closing, they're usually using some clamps, some valves, and technical support is tracking also values on another tank. If there is some changes, they need to warn that technician on the field to close that with another clamp, to make something just to have precise and good calibration.
Very good. So how long does this process take?
This process is usually take 4 to 5 hours per vehicle. So it's not something that is easy to be done. It's something that took effort.
And can you, I mean, you know an awful lot about this process. It sounds like Navixy has support resources available. Can you just summarize how do you make it easier? What are the things that you do to enable better quality calibration?
I mean, like I mentioned, this procedure, you need to provide equipment, clamps, you need to provide a good technicians, experienced technicians on the field. You need to provide that mobile fuel pumps. You need to provide everything that clients doesn't need to do much, They just need to step aside and watch the procedure if they want, and that's it.
Okay, but there's software involved as well. It's not. It's
Yes, of course, because we are putting that configuration inside the GPS device to send data on every 5 to 10 seconds, and in that process, that device is sending only raw data to the Navixy platform, and then we are taking that data and transforming per liters after everything is done, after calibration is done.
Wonderful. Thanks. Okay, Kenneth, your turn. Let's talk about this false positive epidemic. And here's a scenario which you've probably seen. A fleet manager gets 47 fuel theft alerts in 1 month, investigates each one, and discovers 44 of them were false alarms caused by fuel migration between tanks on slopes, what the industry apparently calls gravity fill. After 3 months of this, they stop responding to alerts entirely. How do we break this cry wolf cycle that's undermining the whole value proposition for fuel monitoring?
That's a great question. And as we all know, with receiving unnecessary notifications on our own phones, receiving unimportant notifications on the job leads to the same thing, fatigue. It's just like, oh, look at all these things,
Yeah.
especially if they're not real, it's just like, so then this crying wolf is definitely a problem that leads to more issues down the line. And I believe that the biggest answer here is providing reliable and valid data. And if the data isn't reliable, then provide some options to show why or how. And then expanding more on the alarm fatigue. When real fuel losses happen, they're lost and might not be noticed until later. Monetary losses when real theft happens versus just the fake ones. And yeah, as I mentioned, it's best to have accurate and meaningful alerts. And some options on Navixy include preventing alerts in given areas, like such as geofences, and having multiple sensors connected in aggregate. I believe we'll also discuss this later on, so that way you have like one sensor in each tank. Um, to help discuss the gravity fill portion, because as you mentioned previously, it does go like between when it's on the slope, it gets stuck in the line. Then having more sensors than just a single one will help provide better accuracy. And in the future, hopefully, we're hoping to have AI to learn and predict situations based on the engine and the vehicle type and the speed and the route, or even the driver behavior. Like maybe they're gassing on it heavily, and then that's why you'll see the fuel gauge drop. But yeah, as mentioned, the biggest thing would be to just make the data more reliable, I think.
And is there anything that we can do to segment out different types of alerts so that that people can get a sense of which ones are important and which ones are less important?
I think related to geofences or location alerting could help. Like maybe your truck is parked at the lot, like your dispatcher, the main hub, let's say. And you perhaps you don't want them to alert there, or maybe you want the alert to be less intense, because maybe you got security cameras, and so you just loosen the alert setup, let's say.
Right.
But
Okay,
then
so
if it's outside of that,
context.
yeah, using the context. And so if it's outside that area, then you want to be on like higher alert, and so maybe we could have those just trigger or like set up a little specific message saying like, hey, check this out.
And Navixy enables this sort of thing?
Yeah, we do have this functionality as of right now. Yeah.
Very good. All right. Next question. We're going to go back and let's look at the engineering versus reality gap in a little more detail. So OEMs are designing increasingly complex balancing systems, shuttle valves, active transfer pumps, pressure differentials. But field technicians tell us these systems fail regularly and create diagnostic nightmares. Meanwhile, fleets are modifying trucks back to simpler configurations that break the telematics entirely. Are we witnessing a fundamental mismatch between engineering elegance and operational reality?
There is a reason why trucks manufacturers, OEMs, make things in that way. So, for example, they're putting these dual tanks on both sides to balance, balancing the weight. It's much better to balance. Again, they can travel much longer distances when they have to fuel tanks, and they can arrange their trips much better. But again, in these methods where fuel is moving between one fuel tank to another, it can cause some kind of problems. It can be some kind of problems. For example, the most used method is, we call that old school wisdom, is the method with communicating vessels, and two fuel tanks is connected with one pipe on the bottom, and gravity is doing all the thing, and that's that method number one, and it can be it can cause some problems when that transfer line between two fuel tanks is clogged with some impurity in the fuel or something like that. So that's the reason why fleet managers usually wants to remove one of the tanks from the vehicle. And the second wave, for example, for transferring fuel from one fuel tank to another, is the active transfer pumps. That is more high tech approach. But in that case, there is also a lot of problems. So that fuel pumps is working, and they're controlled by canvas, by the board computer inside that vehicle, and you cannot know every time when that fuel is going to be transferred. For example, you have tank A, and tank A is the main. You have a fabric fuel level sensor in that tank, and you're seeing that the fuel inside that tank is dropping too fast. Your fuel consumption is very high in that moment, and you cannot see what is happening in tank B. And then in some moment, all the fuel is transferred from tank B to the tank A, and you have that phantom refilling. So that can happen, and that is a real nightmare for us, for telematics and for the data. But again, that fuel pump can be malfunctioning in some moment, and then it can be a problem on the road, for the drivers as well. And that is also the reason why fleets removing this kind of equipment from the vehicles.
And so, how much of an issue is it that people make changes to these vehicles and they don't update you? Does that happen a lot?
Yeah, that's happened a lot, and that can be a real problem because we are setting everything up for the two fuel tanks, for the sound values between these two fuel tanks. And then when they removed one of the fuel tanks, that can cause a lot of problems for us, because if they not notify us, if we don't have that communication with the client, then we can experience a big problems with data on the system. So yeah, that is definitely a problem if there is no communication between the client and service provider.
All right, Kenneth, let's talk numbers, numbers that matter in our markets. A typical long-haul truck burns $20,000 to $30,000 in fuel annually in our regions. A 5% data accuracy error, which is common with poorly calibrated dual tank systems, represents $1,500 per truck ghost costs, where fuel usage becomes invisible to the management. For a 100-truck fleet, that's $100,000 to $150,000 in untracked fuel annually. How do we quantify and communicate these invisible costs to clients who see telematics as an expense rather than an investment?
Some telematics products have reporting and alerting mechanisms which are capable of showing this quantified information, and showing examples of this to these clients can help convince them that it's more than just an expense. For example, like these ghost costs, they're difficult to see outside of the telematics scope, without the data in front of you. And so with these tools for measuring and monitoring these values, we can specifically see what's going on and where the failure lies. And investing in these tools can also help with the labor cost while investigating, like the actual issue, or insurance costs and risks. And I know insurance is a big issue as well. It gets expensive here. Then not to mention the proven efficiency. So like if the data is bad, it can't be used or even trusted. But with a history of valid data, this can help optimize routes, coach drivers, or with identifying inefficiencies in vehicles. And if we can demonstrate these costs and results to our clients, such as via our reporting, I think that'll help the client in question decide whether they want a specific product or not.
So, how much of an issue is this? Is the ROI generally accepted, or are people having to get spreadsheets out and PowerPoint and really make a case?
I think it really does depend on like the fleet and where it is. So for example, in the US, we're not quite so worried about like fuel theft, like just fuel theft itself, versus like the Latin American market where they're way more worried about it. So like maybe down there, they're willing to roll out the dough more for these monitoring tools. Whereas up here, they still want that information, but like maybe it's not as intense of a level. But then you still do want to monitor all your information, and so it really just depends on the fleet.
And is that also true of Europe, Nenad? Do you is it first of all, is the trend in terms of fuel theft more like what you've heard in terms of Latin America, or is it more like the US? And what's the view over in Europe in terms of making this business case? Is it a tough sell?
I mean, different markets and different demands from the client, and we need to listen to them all and to provide a service to all. For example, during my conferences, I met a lot of people from this telematics business, and for example, telematics service providers from Middle East are not interested about tracking the fuel at all. That is not a thing. Yeah. For the Latin America, I mean, there is a lot of demands for tracking the fuel. Here in Serbia as well, we work with the fuel a lot. I mean, a lot of calibrations, a lot of different ways to track the fuel and so on. So basically, every market is for itself, and every market is selling a different store.
Well, you got a ton of experience. So we're gonna leave this last question and have you kick it off. So you're specifying a telematics solution for a fleet of 200 trucks, all with dual tank systems. Based on what we've discussed, what's your deployment checklist to ensure that this doesn't become another data disaster? So walk us through the critical steps that separate successful implementations from expensive learning experiences.
Yeah, 200 trucks, that is big fleet for anyone, for any telematics service provider. And that means if all of them have dual tanks, that means 400 tanks and 400 calibrations. So calculate. So you asked me before how much time we need to spend per calibration per vehicle. That is 4 to 5 hours. That is a lot of work. So I divide this into phases, this preparation for this kind of project, because this project is big and this project needs to be taken seriously. So phase number one is the meeting with the owner of the company, with the board. We need to prepare them and to explain to them everything that we are talking about here today. To explain to them that this calibration is going to take a lot of time, this installation as well. So we need to explain to them why they cannot rely simply on canvas information from fabric fuel level sensors from one fuel tank. So we need to explain to them that the best way for this to be done is to install external sensors in each fuel tank separately. So every fuel tank needs to have some measurement system. Imagine we were good on these meetings, and they accepted that our suggestion, and they are going in this way. So they are buying fuel level sensors and advanced DPS device, and that is great. So step number two, phase number two, is to speak with their fleet managers and their team. Now we need to prepare them for this work, for this setting up. We need to explain to them that we will take. Now we need to talk more precisely numbers. For example, we have 5 teams of people, for example, and that 5 teams of people can do 2 vehicles per team daily. So 4 or 5 hours, something like that, 2 vehicles per team. So that means we can do 10 vehicles for you each day. It will take 20 days. They need that information. That information is essential to them because of that information, they will calculate their fleet. They will exclude that vehicles from the drives, from the road trips, and that is very important for us to point out to them. Because then we have less pressure. You will not have someone from site to take you to hurry up. To finish that calibrations and installations and so on. So that's phase number 2, to explain everything to them, to organize them to organize themselves, and their fleet. Phase number 3 is that installing of sensors, calibration, like I explained before, data entering, and that needs to be careful job, carefully done. Everything needs to be precise because we are talking about a fuel that is a very tricky subject. And after all of that is done, kicks in phase number 4, where everyone, most of the telematics service providers forget about phase number 4, and for my opinion, it's very important. You need to leave that data to breathe. After everything is done, calibration and everything is closed up, the vehicle is moving again on the road. We need to check that data in the next month or 2 we need to check recipe from fuel stations, to compare that data from actual fuel pumps with our data. And then we provide tools on our system, besides that calibration table that we have, we also provide fine-tuning filters, filtration thresholds and so on, to make the data more accurate. And that is the main thing. You're closing that whole process with that phase number 4 with checking up on that data. And I will point out one more thing. I'm talking about technical stuff all the time, but we need to think about psychological moment for the drivers. That drivers saw now, okay, they installing some kind of fuel level sensors, some kind of GPS device, some kind of, high-tech equipment. Now they're following me, they will know if I'm stealing fuel. I need to be more careful. They will take care much better now on that vehicle as well. And many times in my experience, I encounter that information from the client that actually after a month or two, they're getting much better results, much less costs on the fuel. Even they didn't touch anything besides that installations. Drivers saw that and now they are afraid. That psychological moment kicks in.
That's a wonderful thing. Yeah, it's sort of a bit like putting the alarm box on the outside of your house.
Yes.
There's actually more value in having that security sticker on the side of your house than actually
exactly.
all the sensors. But you need to actually deliver on that. Well, that's fascinating. I really love the advice on getting executive sponsorship. Step one, everything's going to go smoother if you've got senior management that has understood the ROI and keeps people honest. And I also love the fact that it goes beyond actual deployment. It's not completely set it and forget it. You've got the wherewithal to help with the ongoing aspect. From a personal perspective, I'm really excited to hear about this extension of IoT into fuel monitoring. I was working on a project a few months ago with a client who had literally thousands of vehicles in their fleet, and they've started to put sensors on the assets that go into the delivery vehicles. And we realized when you know what's in the vehicle and you know the fuel consumption of each trip, which you guys have that data now, then we can start to apportion the cost and the environmental cost of on each parcel. So you can better understand the costs of at an item level, and you can tell people that received a parcel, this is the carbon footprint of your particular parcel. So I think now that you're surfacing this data, it can be combined with other things, but it's got to be good data, and I think that's the theme here. So let's wrap it up. The dual tank challenge reveals a fundamental truth about telematics. Sophisticated analytics can't compensate for poor foundational data. Success requires treating calibration and deployment procedures as seriously as we treat hardware selection. So, some practical advice. Establish non-negotiable calibration standards before any telematics deployment. Create separate alert categories for fuel theft and mechanical diagnostics. Build data quality audits into your service offerings. Educate clients that the most expensive part of telematics isn't the hardware, it's the cost of bad data. So, next time, we're going to explore another invisible problem, how the industry's obsession with real-time data is creating bandwidth costs that are quietly eating into telematics profitability, and why the solution might involve going backwards to batch processing. Thanks very much for joining us, gentlemen. Thanks for your wisdom. It's been a pleasure.
Thank you
for having us.